Now that we know what a greatest common factor is and how to find it, we need to talk about what to do with that greatest common factor once we find it. So now we're going to get into actually factoring some polynomials. All right, so here's an example. Let's factor each polynomial by factoring out the greatest common factor possible. Now, what I want to tell you is that whenever you're factoring, and you'll hear me say this over and over and over again, whenever you're factoring, no matter what type of polynomial you have, and you'll see we'll have a lot of different kinds later on, but looking for a greatest common factor is always the first thing you do. You always look for a greatest common factor. Sometimes you'll have it, sometimes you won't, but you always look for one. So if we look at these two terms in this polynomial, we have 3x to the third minus 6xy. So let's look at our coefficients. We have a 3 and we have a 6. The greatest common factor for 3 and 6 is 3. Now, we also have x's that are common to both. We have an x to the third and an x, or x to the first. So remember, we picked the smallest power of x that appears, so that will be x. Now, that y has nothing to do with the greatest common factor because this first term does not have a y. So we don't do anything with this y. Now, what I'm going to do with this greatest common factor that I factored out, right beside it, I want to put an empty set of parentheses. And it needs to be about the size of my original polynomial. Because what's going to happen is something will have to be placed inside of these parentheses. Now, what you need to realize is that factoring is a form of division. So what we're going to do is we're going to look at our original polynomial, and we're going to look at our greatest common factor. When we pull this greatest common factor out of each one of these terms, what we're actually doing is dividing each one of our original terms in our polynomial by that greatest common factor that we pulled out. Now, as we go through the problems, this is a step that we'll be able to do mentally, but you need to understand where we get the terms that go inside of the parentheses. So once you identify your greatest common factor, divide each one of your original terms by that greatest common factor. Now keep in mind, these x's have understood ones as exponents. So when we simplify each one of these, we're going to use our quotient rule, if you remember your quotient rule for exponents. So here we just reduce this, 3 over 3, this will just cancel. We have x to the third over x to the first. If we use our quotient rule, we're going to subtract 1 power from this 3, so that's going to leave us with x to the second power. Minus, just bring this sign down. Here we reduce this 3 into 6 2 times. Here we have an x to the first and another x to the first. They cancel each other out, but we have to hold on to this y. So that's going to give us 2y. So this is our polynomial that has been factored. We factored out our greatest common factor, and we wrote down inside of our parentheses what's left over once we factor that out. Let's look at another example. All right, this one looks a lot worse than it really is. So we just want to look at it in pieces. Let's look at our coefficients to see if we have a common factor. We have an 8, we have a 4, we have another 4, and we have a 16. So for 8, 4, 4, and 16, all of those numbers are divisible by 4. So for the coefficients, the greatest common factor is 4. All right, let's see what else we have in common. They all have a's. The first term, we have an a to the third. The second one, we have an a to the second. The third one, we have an a with an understood power of 1. Same thing for the last one, we have an a with an understood power of 1. So for my a's, the greatest common factor is a to the first, smallest power. And let's look at our b's. We have a b to the third, we have a b to the second, we have another b, and we have a b to the second. So for all of our b's, the smallest power that appears on b is here. So our greatest common factor for our b's is b to the first. Now, I need an empty set of parentheses. And what goes inside of parentheses is what's left after I divide each one of my original terms by my greatest common factor. So I'm going to have my 8a to the third, b to the third, divide that by 4ab. I'm going to have to take my minus 4a squared b squared, divide that by 4ab. We take positive 4ab and divide it by itself, 4ab. And we divide our 16ab squared by 4ab. So now let's just simplify each one of these little fractions. So our 8 over 4, that's going to reduce. That's going to give us a 2. We have 3 powers of a on top and 1 on the bottom. So this should simplify, leaving us with 2 powers of a. And the same with our b's. We have 3 on top, 1 on the bottom, so that should leave us with 2 powers of b. So when I simplify this, I have 2a squared b squared. And for this next one, the 4's will cancel. I have 2 powers of a on top, 1 on the bottom, so that will leave me with 1 power of a. I have 2 powers of b on top and 1 power of b on the bottom, so that should leave me with 1 power of b. So the 4 will cancel. I'll have 1 power of a and 1 power of b left. Bring my sign down, so that's going to leave me minus ab. Now notice this is just something divided by itself. 4ab divided by 4ab. Anything divided by itself is 1. The 4's cancel, the a's cancel, the b's cancel. Keep in mind this is division, so that's plus 1. And the last term, 16 divided by 4, so that's going to simplify, giving us a 4. And then the a's will cancel, and I should have 1 power of b left over because I have 2 on top and 1 on the bottom, so that gives us plus 4b. So this is the factorization of our original polynomial. Now, let's look at another example. Here we have a times the quantity x minus 3 plus b times the quantity x minus 3. So in this one, our common factor is the binomial expression x minus 3. So that's our greatest common factor. So we're going to write that down. And now I need an empty set of parentheses. And let's see if we can do this without actually writing the division step. We have a times the x minus 3, and we factored it out. So the only thing that's left is the a. We have the plus b times the x minus 3. We factored it out, and we're left with the plus b. So that's my factorization. There's nothing else that I can do to that. Here's another example. Three times the quantity x plus 2 cubed minus the quantity x plus 2 squared. Now I want you to notice something here. If you look at this second set of parentheses, there's nothing in front of it. But there really is something in front of it, it's just not visible. Keep in mind that anytime you see a variable with no number in front of it or a set of parentheses with no numbers in front of it, that number is really understood to be a 1. So for a problem like this, if you encounter something like that, just go ahead and put that 1 down, because it's going to help us as we go through the problem, and you'll see why in just a minute. So let's look at this. 3 and 1 really don't have anything common other than 1. But I do have the binomial x plus 2 that's common. I have an x plus 2 to the third, and I have an x plus 2 to the second. So my greatest common factor will be that binomial factor of x plus 2, but I picked the smallest power, so that's x plus 2 squared. Now I need my parentheses. So when I factor 2 powers of this x plus 2 from this first term, I'm still going to have that 3 left over, but I also have a single power of x plus 2 left over. So there's my 3, and there's the x plus 2 to the first. Started with 3 of them, factored 2 of them out, I have 1 of them left. Now, if I look at this last part, x plus 2 squared is what I factored out. So this x plus 2 squared is gone completely, and the only thing that's left is the minus 1. So for the factoring, I'm really done with this problem, but I can clean it up a little bit. Anytime you have problems and there's some cleaning up that can be done, just go ahead and do that. And what I'm going to do is I'm going to distribute this 3 through the parentheses here and then combine my like terms. So I'm going to multiply the 3 times x and the 3 times 2. So when I rewrite this, I'm going to bring my x plus 2 squared down, and then that's going to give me 3x, and the 3 times a positive 2 is 6. Bring down my minus 1, and then go ahead and combine our like terms. So we're going to get x plus 2 squared, and then this will give us 3x plus 5. There's nothing else that we can do to clean this up. So that's my answer. Now, just a note, as I mentioned, no matter what type of polynomial you are given to factor, the first rule of factoring is to always check for a greatest common factor. Oftentimes there won't be one, but that polynomial might still be factorable by other methods. So we're going to talk about that a little bit later. We're going to have different types of polynomials, and you may have to approach them differently. Just because they don't have a greatest common factor does not necessarily mean that they cannot be factored.